Hey, my name's Steve. Welcome to my YouTube channel. In this video, I will introducing you the L'Hopital's rule. L'Hopital's rule. Usually, we use this rule to evaluate some indeterminate forms of limit, such as like 0 divided by 0 or infinity divided by infinity forms. The limit is equal to its derivatives. So here is a little bit history of this L'Hopital's rule. This L'Hopital's rule is named after a French mathematician, L'Hopital, in 1696. But it is believed this rule was introduced by Bernoulli 2 years ahead to L'Hopital. Under this rule, we have the limit of these two functions fx divided by gx when x is approaching to c. C could be 0 or infinity or any number. Is equal to the limit of the differentiation of fx divided by the differentiation of gx. X is approaching to the same number, c. Okay. We have three conditions for using this L'Hopital's rule. The first one is when fx and gx at point c equal to 0 or infinity. And the second condition is we have fx and gx has to be differentiable at point c. And the last condition is the limit of this derivative has to be exist. Okay? Okay, we try to using this L'Hopital's rule to do some exercise. I give you 4 questions to do here. Okay, this one. The limit of sine x divided by x when x approaching to 0. So when x is approaching to 0, sine x is equal to 0. X equal to 0. So we are having a 0 over 0 form, right? So under the L'Hopital's rule, we have this one equal to the limit x go to 0. The differentiation of sine x equal to cos x. The differentiation of x equal to 1. Then we have when x is go to 0, cos x equal to 1. Here is 1. So the limit is equal to x go to 0, 1 over 1. Okay, so 1 over 1 is 1. So finally, the limit of sine x divided by x is 1. If without this L'Hopital's rule, when we're doing this limit, we are assuming sine x equal to x when x is very, very small. So we are assuming sine x is equal to x when x is really, really small. Then we can say, because they are the same, then we can get 1. But under the L'Hopital's rule, we can get a 1 exactly. So the sine x, the differentiation of sine x equals cos x. The differentiation of x equal to 1. When x is approaching to 0, we have cos 0 is 1. Then we have 1 over 1 is 1. So the final limit is 1. Okay? Fairly small. Okay, the second question is the limit of e to the power of x divided by the x squared. When x is approaching to positive infinity, e to the power of x approaching to infinity. X squared is approaching to infinity as well. So we are having infinity divided by infinity forms. Okay, so under the L'Hopital's rule, this limit is equal to the limit x is approaching to infinity. Ex, the differentiation of the ex is also ex, equal to x squared equal to 2x. Right? But at this step, when x approaching to infinity, e to the power of x is still infinity. E 2 times x is still infinity. So we are still having a infinity over infinity form. What can we do at this step? We can keep going we can apply the L'Hopital's rule another time. 2 times. So equal to the limit of x when x go to infinity, ex, we still have ex. The differential of 2x, we have 2. Then we are not having a infinity over infinity forms. So here we are having an infinity over 2. A 2. So an infinity over 2. So when x approaching to infinity, so this one is approaching to infinity divided by a specific number. So at the end, the limit is infinity. Okay. The L'Hopital's rule is not always work at these two forms. Not always at these two forms. For example, this question we can't use L'Hopital's rule. For example, when x is approaching to infinity, we have this x approaching to infinity, this x approaching to infinity, but cos x we can't confirm this value because cos x is in a range from -1 to 1 when x goes to infinity. So even though we are applying the L'Hopital's rule, for example, the limit x goes to infinity, the differential of this one would be 1 minus sine x divided by 1. When x approaching to infinity, we can't tell the value of sine x. This one could be 0, could be 1, could be -1. So at the end, the limit, we are not sure. That's why in this limit, we can't use the L'Hopital's rule. We're just using a normal method to find the limit of this one. For example, equal to, we can divide by x on the both sides. We have the limit x go to infinity. Both sides divided by x, we have 1 plus cos x divided by x, and then divided by 1. Okay? And this number, when x goes to infinity, because this one is limited at -1 to 1, and divided by an infinity number, which means this part is approaching to 0. So this one is approaching to 0 when x approaching to infinity. This one is 0 at the end. So this one is 0. We have 1 divided by 1 for the next step. The limit x go to infinity of 1 over 1 equal to 1. Okay, so in this example, we can't use L'Hopital's rule. Just using the normal method, we divide by x on the both sides and then get the limit at the end. Okay, so in question 4, I'll leave you for your homework. Okay, so the limit of 3 sine x minus sine 3x divided by x minus sine x. So when x approaching to 0, so we have 0 minus 0 over 0 minus 0. So here is a 0 over 0 form. But we need to apply the L'Hopital's rule 3 times. 3 times to find the limit of this one. So the final answer is 24. You can try this question on your own, okay? So final answer is 24 after 3 times applying the L'Hopital's rule, okay? Yes, that will be all for this video about the L'Hopital's rule. And I'll see you in next video. Hopefully, my video will help you to have a much understanding about mathematics. If you like my video, please give me a like and subscribe my YouTube channel. I'll see you in next video. Bye-bye.